Hello, today the video is in English because I had last time also a lot of international requests because quite a few people want to know how to migrate the old locomotives from MacLean to the digital world. And I want to demonstrate here again the cheapest way really to do it. And the basis is here, for example, an old MacLean motor, in this case here, the large flat collector motor. We want to shortly explain it, and then very cheap migration. Here, for example, with the ESU magnet, who just replaces here the field coil, so this part, and you just pull it out and put the magnet in, and then you have migrated the motor. Super simple. Let's still go for the differences. The old motor has here in total 3 connections. So it has on the left side and right side connection to the field coil, because the transfer from forward moving to reverse backward moving is over this field coil. On the left side you have the field coil forward, and on the right side the wire goes backward. And then when the wire is in the different way, in the backward way, the magnet that will be created when you have here a current in the field coil will be reversed. And this is in the old analog motors how you change from forward to backward, and you still have another piece, a relay to move between these two connections. So, and then you have here the connection between the inner and the outer part, because in the inner part, as we can see, we have here the anchor, and in the anchor also we have 3 field coils, as we can see, and this is why the old motor is called a 3-pole motor. And the modern motor, when you change to a modern motor, you have 5 field coils, so a 5-pole motor. And the connection between the outer part and the inner part is here over the carbon, and wire piece that is put here into the holes. Because you see, I have here already connected 2 wires. We connect from the outer part, and over the carbon, which leads the current, it goes to the inner side, to the anchor. And so the field coils in the anchor are electrified, and also cause an inner magnet. And this is how the motor can turn, because you have 2 different magnet fields, and as the anchor turns around, the field is always changed, and it can continue. Well, when you work with a modern digital locomotive, you don't need this field coil anymore, because the change between forward moving and backward moving is done over the decoder. So you use here a permanent magnet. For the large flat collector motor, this is the ESU magnet 51960, and this one always fit. It only doesn't fit for the super old locomotives from the early 1950s. Yeah, so you have to verify to put this correctly in, that it really fits. So. And then you put the anchor with the motor shield and the carbon. The two carbon, they hold, they're fixed here with two wires, so there you get the connection, and then you just put this on. So I have now only one hand free. Let me see. Well, I can guarantee it fits there. So and then you put here the two screws, one here and one here, and then you fix it with two screws, and your motor is ready for digital use. So it's a super simple way, and this magnet only will cost 8-9 euros. So it's really the cheapest way to do it. Of course, the other way, more elegant way, is to change the whole motor. And McLean offers also 3 different kits, depending on what type of motor it is. Here for the large flat collector motor, you can purchase a complete new motor. That would be in this case with the order number 6944. Yeah. Okay, when you only use the ESU magnets, then you also should use an ESU decoder. For example, I use here now a very simple one, a LokPilot 5. So LokPilot 5 means it doesn't have a sound, so it's not a sound decoder. So we take here the 59619. It is a decoder here with 21 MTC interface. Yeah, you see here on the top the 21 holes. So, and then you need here an interface to put the decoder in, so you can wire your decoder then with your railway system and with the motor. So I'll show you what the most important wires are. So you see here also the 21 pins on top, and you just switch the decoder on. Why is it very good to have these two parts? Because then you always can later on, if you want to in later years again modernize your decoder, then you just clip your decoder off and put another newer decoder on. So let me just see this. I had this. So this is here the order number, the ESU order number for the interface, which I use here, 51967. It is really the simplest one. There are even more complex ones. So there's a variety of interfaces you can choose. But this one here is the most simple interface you can here use, and you can see here also in the description. So it's numerated here, the 21 pins. Yeah, it's really what you see here, where you put your wires on. So, and 22 for example, then goes to the positive current on the railway, 21 to your ground potential, to the zero potential on the railway, and 19 and 18 goes to the motors. So, and again, let me explain now. When you have this permanent magnet, then you only have two connections, right and left of the motor. And we remember that here with the field coil, with the old analog motor, we had here already two wires on the field coil, and one wire went out of the field coil. Let me see. This was this one. So in total you had 3 connections. Since we have now here a permanent magnet, so we don't have anymore the 3 connections. We only have 2 connections left. Yeah, and the 2 motor wires you can connect vice versa. It doesn't really depend. If it's not correct for you with forward and backward moving, then you just switch the 2 motor wires and it will be correct. Okay, and then you have a lot of other wires, for example, for your lights, or for your sound if it is a sound decoder. But in this case it's not a sound decoder. And then you can have also have wires for power capacitor if you want to buffer your locomotive. But we want to keep it today super simple, so only 4 wires are really needed that your locomotive will run. So it is here. When we look again, it is here now the red wire, red for positive current, the brown wire for negative current going to the railway. It's not sharp now. So, and then we have the green and blue wire for the motors. And the white wire which we see there in between is for the ground connection for the buffer capacitor. So don't mix up the ground or the negative for the railway. Oh, it's not sharp now. So with the ground for the buffer capacitor, it's not the same. So if you put these 2 together, then the ESU decoder will burn and will fail. Yeah, so the buffer capacitor do later. Lights and buffer capacitor do later. Very also when you migrate very old locomotives and you have problems, and it's also very often caused by defective lights. Yeah. Therefore, in first instance, never connect the lights. So do it first without the lights. Just first try if you get your motor running. And we see here with this ESU magnet, it is super simple. So it will already run. But what I have not mentioned, because this is now only the hardware, we also need to program our ESU decoder with the ESU Lock programmer for an optimized run. So it will already, if you program nothing, it will already run, but it will not be optimized for this motor, because it is here a 3-pole motor. I said the anchor inside has 3 field coils, so it's a 3-pole motor, and we have to program it for a 3-pole motor. And therefore you need the software for the ESU Lock programmer. So the software for the ESU Lock programmer you can download to your PC, but then you still need the hardware for the ESU Lock programmer, and that is not very cheap. You can calculate round about 150 euros. Yeah. So this is today not part of the video, the lock programmer. We only wanted to talk here about the motor and the ESU decoder connections. Okay, thanks a lot.